Now let's move on to question 6 of the 2025 H2 Math Specimen Paper 1. So question 6 is a vector question. So let's take a look at this question here. So we are given in part A that the non-zero vectors A, B, and C are such that A cross B equals to C cross A. And given that B is not equals to C, find a linear relationship between A, B, and C. Okay, so for such a question, right, what we will do is both of them contains A, right? So what we can do here is we can move A to all one side. So I have A cross B, E minus C cross A is equals to 0. And the next thing I know is that for cross product, C cross A is not equals to A cross C, right? Okay, but rather they are opposite vectors. So C cross A is equals to negative A cross C. So what I'm going to do here is I'm going to change the sign of this. So this one will now become negative A cross C, and negative becomes positive. So this is what I have. Right? So now when I reach this point here, I can factorize out A. Okay, so when you cross two products when you cross two vectors and you get 0, what this means is that either one of them is a 0, or these two vectors are parallel to each other, right? So we are given some information, right? A, B, and C are non-zero. So that means we know that A cannot be 0. In addition, we also know that B is not equals to minus C. That means B plus C cannot be equals to 0. So, since A is not 0 and B plus C is not 0, so the only thing we can conclude from here is A is parallel to B plus C, right? So we can rewrite it as A equals to K B plus C, where K is real. Okay, so that is what we do for part A. So let me write the answer. So we have A cross B equals to C cross A. So A cross B is equals to negative A cross C. Then I'm going to move everything over. Factorize out A. You notice that for this type of proving, right, whether it's dot product or cross product, usually you try to factorize them. Alright? Okay, then since A is not 0, B plus C is also not 0 because given B is not equals to minus C. So therefore, A is parallel to B plus C. A equals to KB plus C, okay, where K is real. Okay, so this is our answer for part 6A. Now let's move on to B part 1. So next we are told that the variable position vector V satisfy this equation. V equals to I minus 3K equals to 2J. Then they ask us to find the set of position vectors V. Okay. So what should we do for this? Right. So there are many ways to solve this question, but what we like a lot in math is to equate one side to 0. Okay? If it's dot product, if two vectors multiply dot product is equals to 0, that means they are perpendicular. If two vectors, when you do a cross product, it becomes 0, then they are parallel, right? So we are trying to make one side 0. So how do we make one side 0? So we want to find a set of position vectors V, right? So what we'll do is, let's write this out first. V cross I minus 3k equals to 2j. Okay, 3k equals to 2j. And remember I say we like 0. Okay, because once we have something equals to 0, it is easier for us to come up with a relationship. Okay, so how do we make one side 0? Remember, in order for cross product to be 0, what does it mean? Well, it could mean that, okay, when I cross two vectors together, they are parallel to each other. So what I'll do is, since let's take a look at this, okay? Let me call v cross I minus 3k as maybe vector w, and this 2j is just 2j. So if w is equals to 2j, what happens if I take w times another vector b? It will also be equals to 2j cross b, right? Because w and 2j are equal, right? So if I cross them with another same vector, you'll get the same thing for the cross product. Okay, and so this is what we are going to do. So if you take a look at this, I want to make one side 0. It's easier to make this side 0 because it only has like one vector here. So what I'm going to do is I'm going to take 2j cross with j, because j is parallel to j, right? So when you take j cross j, it will be equals to 0, because when you cross parallel vectors together, you get 0. So this is what I'm going to do. I'm going to cross with j here. Okay, and remember j cross j is 0, so this part is now 0. Okay, and I'm going to write this as 1, 0, minus 3. I'm going to write this as 0, 1, 0. Alright? Okay, so once you have done this, the next thing you need to do is to do a cross product for this one. Okay, so let's do a cross product for this now. Okay, and you will get, this will give me 3, 0, 1. So I know that v cross 3, 0, 1 is equals to 0. So from part 1, there's some hints on part 1, right? So we know that when you cross two vectors together, you get 0. That means, and they are non-zero. So what does that mean? Well, it means that they are parallel to each other. Okay, so if you look at this, did they say v is 0? Oh, they didn't say that v is non-zero, right? Okay. So they didn't say that v is non-zero, but this is obviously non-zero. Okay, so we can write that, okay, or v is parallel to 3, 0, 1. So in other words, v equals to k 3, 0, 1, but I've already used k in part 1, so maybe I won't use k. Let me use lambda. Okay, so now, so this is the set of position vectors for v. So v can be anything that is equals to lambda times 3, 0, 1, where lambda is a real value. So lambda can be 1, lambda can be 6, and so on. Okay, so that's for part B1. Next, you're asked to describe the set of points represented by the position vector v geometrically. So we take, see, v takes this equation, right? So what is it? This looks like an equation of your line, right? Your equation of line is equals to, for line, okay, vector equation of line is r equals to a plus lambda b, right? Where lambda is real. So there is no a here, right? If you compare these two here, your vector v is like vector r, so it is any point on a line. There's no a, so we can assume that it is plus 0, 0, 0, right? Okay, but don't need to write. So we can say that v is any point on the line passing through 0, 0, 0, or passing through the origin and parallel to 301. Okay? Because this looks like the equation of the line, so this is how you described it. So V is any point on the line passing through the origin, okay, or 0, 0, 0, and parallel to 301. All right, so this is how we interpret this relationship. Now, moving on to question 7. So you're asked to show your working, find the complex number z and w which satisfy the simultaneous equations here. Okay, and they say do not use the calculator in answering the question. You can use the calculator to check your answer. Okay, which I highly recommend. You can get this 6 marks, right? But after you get the answer, sub in your z into this equation, your w into this equation, check whether you get 4. Then do the same for the second equation, sub z in, sub w in, see whether you get 3. If you get it, okay, that means you'll get your 6 marks. All right, so now let's go to this. So we have these equations here. Let me copy it here first. Okay, so you know that for this type of simultaneous equations, right, there are 2 ways of solving it, right? One of it is you just try to make either w or z the subject, okay, and then just solve. It's like a simultaneous equation. It's just that it involves arithmetic involving your I. All right. Another way is you let z please be a plus bi, where a and b are real, and w be x plus iy, where x and y are real. Then you sub it in, then you solve real equals to real, imaginary equals to imaginary. So for this question here, we will not use this one. Reason is because both of them are z, both of them are w. You only use this method if you have z and conjugate of z, or you have mod z somewhere. Okay, this does comes out in the A level, but just remember that if you see z here, this is also z, not mod z, not conjugate of z. You see w here, here is also w, not mod w or conjugate of w. Then you just don't need to do this. This is more tedious. You can just make either z or w the subject, okay, and then sub it into the other equation. All right. So with that, let's do this question together. All right. So now let's start off with these 2 equations, and we need to make either z or w the subject, right? So if you have to look at this, okay, 2i plus z, blah, 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 blah. And here you notice that the z is multiplied by 1 plus I, a complex number. This one is just multiplied by a single term. So it means that it's going to be easier to make z the subject using equation 1. Okay, for w, both of them are multiplied by a complex number. That means your a plus bi instead of just like your bi or your a. So it's going to be harder or more tedious to make w the subject. So I chose to make z the subject. Okay, so now let's do that. So from 1, okay, I have 2iz equals to 4 minus, okay, I'm going to bring this over, right? 1 minus 2iw. So 2iz equals to 4 minus w plus 2iw. Next, I'm going to divide everything by 2i. So this is 4 over 2i minus w over 2i plus w, because 2i divided by 2i, you can cancel them. Okay, so now that I've done this, I need to evaluate what is 4 over 2i. I recommend using the calculator, but I'll show the working. I multiplied by 2i on both sides. So 4 over 2i, if I have to type it into the calculator, it gives me negative 2i, right? Yeah. Okay, so then next I'll do the same for this. I'll type minus 1 over 2i into the calculator. Okay, but before that, I want to show them that I did not use the calculator. Okay, just need to show them what you did. Okay, for such simple things, you don't need to show again, like 4i over negative 2. So it's negative 2i. Okay, so you have iw over 2i square, right? So 2i square is minus 2. Oops. So basically it's equals to plus half I, right? Or you just need to type in negative 1 over 2i in your calculator. You also get plus half I. Okay. So this is what we get. Z is equals to negative 2i plus half iw plus w. And I'll label this as equation 3. Next, I'll sub 3 into 2. Okay. So let's do it. So I have 1 plus I. Okay, then I have z, which is this, right? Minus 2i plus half iw plus w. Then plus 2i times w. So maybe I'll expand it because anyway I need to expand it later. So I'll just expand it now. So it'll be 2w plus iw equals to 3. Next, I need to do an expansion. So take 1 multiplied by everything here is basically just copying everything inside this second bracket. Then multiply I by everything here. So it is I times I is minus 1, right? So here is plus 2 because minus 1 times minus 2 is plus 2. Be very careful when you do this because it's very prone to careless mistakes because there's so much things to multiply. Okay. So once we have done that, okay, let me do a quick check to make sure that my answer is correct. Seems okay. Okay, let's continue. So next I'm going to simplify them. So all the terms with I only have one term with I here, right? Okay, you know what? I'm going to bring these terms to the other side because I want to make W the subject, right? So every term with W, I'm going to factorize them out. Every term without W, I'm going to put it on the other side, right? Okay, so this is what I'm going to do. So I'm going to bring 2 and minus 2i over. So 3. So when I bring 2 over, you have 3 minus 2, which is 1. When I bring minus 2i to the other side of the equal sign, it becomes plus 2i. Okay, then the rest of the terms that are remaining has w. So let me factorize out my w. Okay, then next let me use. So for those terms that are of iw, let me just underline them. So I have 2iw plus half an iw. So I have 2.5 iw or 5 over 2 iw. Okay, and then here there's a w already. Next, I have the rest of these terms here. W minus half w plus 2w. So it is equals to 2.5 w, right? Let me check. Wait, w plus, so this 3w, okay, then minus half a w, yeah, so it's also 5 over 2w, okay, and w I already factorized it out already. Am I right? Okay, so now I'm done with this. Okay, so I know that basically I have 5 over 2i plus 1 here, right? So in other words, when I multiply, I can multiply both sides by 2/5. So this one will cancel off, right? So I have 2/5 plus 4/5 I. Okay, actually I shouldn't do it this way yet. I'll just keep the 2/5 outside. Plus 2i. Then my w, I need to divide it over, right? This 1 plus I. So this is my w, 2/5, 1 plus 2i over 1 plus I. Okay, then next I need to multiply top and bottom by 1 minus I, because I cannot have complex number in the denominator, it's not simplified. Then I know that 1 plus I times 1 minus I is basically 2. Recall, 1 plus I, 1 minus I is like your A plus B times A minus B is equals to A square minus B square. So it's your 1 square minus your I square, and I square is minus 1. Minus 1 minus minus 1 is plus 1. So it's 2, right? So that is how we got 2 here. Next, continue multiplying. So I have expanding this. So take 1 plus 2i multiply by 1 minus I. So I have 1 minus I plus 2i, then plus 2. Because 2i times minus I is 2 times minus 1, which is negative 2. Then with a negative sign, it becomes positive 2. Goes to 2/5. Let me cancel. So I have left with 1/5. And I have 3 plus I. So I got the answer for W. So W is equals to 3/5 plus 1/5 I. Okay. So typically, what I'll suggest to students, while you're doing the expansion, while you're showing the expansion, type it into the calculator. Make sure you get the same answer. Okay, then you're done. Okay, then next, we need to find Z as well, right? Okay, so I need to sub W into Z. So sub 4 into 3, because I need to find Z. So Z is equals to minus 2i plus half I 3/5 plus 1/5 I plus 3/5 plus 1/5 I. So typically when I reach here, I'll tell students type it into the calculator, get the answer. Okay, if you have no time, done. Okay, if you have time, then you just pretend you have expanded. So it's minus 2i plus 3/10i plus 1/10i squared. So it's minus 1/10. Then plus 3/5 plus 1/5 I, right? Then just add everything together, simplify everything. You should get Z equals to half minus 3/2i. Okay, so for this question, your W is equals to 3/5 plus 1/5 I, and your Z is equals to half minus 3/2i. Okay, then if you have the time, so for this type of questions, right, you don't check from top to bottom again. Once you have gotten the answer, okay, you sub your Z and your W into this equation. See whether it satisfies question 1. So the left hand side is equals to the right hand side or not. So type in the value of your Z and your W into this equation. Okay, type it into your GC, check whether you get 4. Do the same for equation 2. So if you get 4 and 3, that means your answer is correct. Alright, now let's move on to the part B. So for part B, you are given that points A and B on the Argand diagram represents the complex number W1 and W2. Okay, on the copy of the Argand diagram in the printed answer booklet, plot C to represent the complex number W3, where W3 equals to W1 plus W2, show the geometrical relationship. So remember when we learned about the complex numbers, they are like vectors, right? So in other words, right, this is W1. W1 is like OA. Okay, O is the origin. Then W2 is like OB, right? So W3, which is like your OC. So that means because C is going to represent W3, right? So OC is going to be equals to OA plus OB. Okay? So this is OA plus OB is equals to OC. So you can use the parallelogram rule, right? So this is A, this is B, this is O. So if I were to complete the parallelogram, this point here will be C. Okay, so C, okay, is the point on OACB such that OACB is a parallelogram. So you need your ruler. Okay, so let me draw this. So you need your ruler, right? So once you have used dotted lines to join this, next what you need to do, you need to draw a line parallel to OB. Okay, AC is such that AC is parallel to OB and they are of the same length. Okay, then you can do the same to find this point. So what we'll do is we'll just draw parallel lines, a line parallel to OB that passes through A. Then again, the same thing, a line parallel to OA, then passes through C. Okay, then you'll get point C here. All right. Okay. Okay, so this is my point C. And I know that, right, this is parallel to this. This is parallel to this. Okay, and these are the same length. Okay. Okay, so I found C already. So next, A prime, B prime, and C prime represents complex number I, W1, I, W2, and I, W3. So when you multiply a complex number by I, okay, what it means geometrically is you are going to rotate W1, okay, or you are going to rotate the point 90 degrees anti-clockwise, okay, about the origin. So this is A. So now I'm going to rotate it 90 degrees. 90 degrees clockwise, okay, about the origin. So I'm going to draw a perpendicular line to A, to OA. So this is OA, right? So this is a perpendicular line. Measure this length, then this one will be A prime. Okay, then do the same for C and B. Okay. Let me do this. Then I'm going to draw a perpendicular line. Okay, then measure this length, then I should have C prime. Then do the same for B. Need to rotate OB 90 degrees anti-clockwise, so it should be roughly here. Okay, so that is how we got A prime, B prime, and C prime. So what is important from this part is when you multiply a complex number by I, you are going to rotate it 90 degrees anti-clockwise about the origin. Okay. Okay, so next I have already drawn A prime, B prime, and C prime. Next, they are asked to state the transformation that maps A, B, and C onto the point A, prime, B prime, and C prime. So basically, it is to rotate 90 degrees, rotation of 90 degrees, okay, anti-clockwise about O. Okay. Next, part 3, the transformation in part 2 maps A1 into A prime prime. So the transformation in part 2 maps A prime into A prime prime. So basically, what is this transformation? It's basically rotation 90 degrees anti-clockwise about O, right? So now to go from A prime to A prime prime, I'll rotate this O A prime 90 degrees again anti-clockwise about the origin, right? So let me use orange. Okay, so now again another 90 degree, right? So this is my A prime prime. Okay, so basically this is another 90 degree. So from A prime to A prime prime, it is basically an anti-clockwise rotation about the origin by 90 degrees. Okay, so from A to A prime prime, it is 180 degrees rotation about the origin. So next, what do they ask? Determine with justification whether A prime prime represents the conjugate of W1. So if I were to let W1 be equals to A plus BI, then IW1, okay, is equals to AI plus BI squared, right? Which is negative B plus AI. Then now I'm going to multiply this I W1, right? Which is equals to my W, which is represented by points A prime prime. This one is represented by points A prime. Okay, will be equals to, I multiply this by I again, so this minus BI, okay, plus AI squared, which is equals to negative IB minus A. So if we were to compare this with this, A plus BI versus minus IB minus IA, are they conjugates of each other? No, they are not, right? It's just negative of each other, so it's not a conjugate. So the answer is no. Conjugate of W1 is A plus BI. Let W1 be A plus BI, where A and B are real. Conjugate of WI is A minus BI. Okay, but complex represented by A prime prime is minus A minus BI. So therefore, they are not this. So A prime prime does not represent the conjugate of W1. All right. Okay, now that we've done question 7, let's move on to question 8. So question 8 is a parametric equation type of question. So the curve C has a parametric equation x equals to cosine cube t, y equals to sine cube t. Okay, so you're asked to find the equation of the tangent to C at point P with parameter P. So basically this is a parametric equation type of question. Okay, so let's go to question 8. Okay, so I'm given x equals to, so let's write again, x equals to cosine cube t, y equals to sine cube t. Okay, and I know that t is in between 0 to pi over 2. Okay, then I need to find the equation of tangent at C where t equals to p. Okay, so I need to find the tangent at t equals to p. So the first thing you need to do to find a tangent is you need a point and a gradient, right? So to find gradient, what I'll do is I'll first find dx dt and dy dt, and from there find dy dx. So differentiate x with respect to t. I'll have 3, copy down the power minus 1 cosine square t, then differentiate cosine t, which gives us minus sine t. Okay, then find dy dt. So again, bring down the power minus 1, and then differentiate sine t, which will give us cosine t. Okay, next dy dx is basically dy dt over dx dt. So you have 3 sine square t cos t over minus 3 cos square t sine t. Okay, so the 3 can cancel, the cosine can cancel, one of the cosine can cancel, so you'll be left with sine t over cosine t, which is your tangent t. Okay, or let me just write it as sine over cosine for now, because maybe later I need to cancel cos t. Okay, at t equals to p, it is equals to sine p over cos p. Okay, then next, okay, at t equals to p, equation of tangent, okay, will be y minus sine cube p equals to sine p cos p, okay, x minus cos cube p, right? Then let's simplify it. So this one will be sine over cosine p. I think I can just keep this as tangent p now. Sorry, negative tangent. There's a negative. Okay, negative. Then for this one, I'll multiply it in, so it's plus sine p cos square p. So make y the subject. Okay, so this is the equation of the tangent. Oh, I forgot my x, so I need to put the x here. Okay, so it is y equals to negative x tangent p plus cos square p sine p plus sine cube p. Alright, so we're done with part A. Let's go on to part B. The tangent at P meets the x-axis at point A and meets the y-axis at point B. Find the length of AB. So that means when it meets the x-axis, y is 0. When it meets the y-axis, x is 0. Okay, so let's do it. So when y is 0, okay, or maybe let me do when x is 0 first. Okay, so I know that y is equals to sine p cos square p plus sine cube p, right? So this is point B, right? So B is 0, sine p cos square p plus sine cube p. Okay, next I want to find A. So that means when y is 0, I'll have so this is 0, right? So this y is 0. Okay, I'll bring this over because I need to make x the subject. So erase this. Okay, so tangent is sine over cosine. Okay, is equals to sine p cos 2p sine plus sine cube p. Then I want to find what is x, right? So I will divide everything by sine p over cos p. So that means it's the same as multiplying it by cos p over sine p. So this is square. Okay, which way I simplify, I have cos cube p plus cos p sine square p. So therefore I know A is this cos cube p plus cos p sine squared p, 0, right? So now that I've reached this point, I need to find length of AB. It's basically this minus 0, which is basically just this squared, minus this minus 0 squared, which is basically just this square. Then square root the whole thing. So it's basically cos cube p plus cos p sine square p square plus sine p cos cube p plus sine cube p square. Okay. So what we can do now is basically factorize it, right? So what I'll do is I will factorize cosine out. So if I factorize cosine here out, right, cosine p here, there's a square. So I still need to give it a square. Then what I'll be left here is cosine square p plus sine square p. And I know that is equals to 1, right? Do the same. Factorize out sine p, put a square. Then I have cosine. I think I have, oh, this is sine cos cube. Okay, then this one. This is square, sorry, it's not cube, it's square. Okay, so this is 1, right? This is 1. So what I'm left with, cos square p plus sine square p. And this is 1, so square of 1 is 1. So the length is 1 unit. So for this part here, right, I want you to remember certain things. Okay, if I have AB plus AC square, there's a square here, right? So if I have to take out A here, you must give it the square. Alright? Okay, don't miss this out. Okay, so we are done with 8B. Let's go on to 8C. Show that the Cartesian equation of C may be written as this. So whenever you need to convert a parametric equation to a Cartesian equation, if you have just algebra like x in terms of t and y in terms of t without trigo, then what you will think of is to make t the subject and then sub that into another equation. But if you have trigo, use identity. So you have cosine and sine. So what you need to think of is your cos square t plus sine square t equals to 1. Okay? So that is what we are going to do for this one here. Okay, so I think I write too big. Okay, so let me just draw a line here. So this is my 8C, okay? So I know that my x is equals to cos cube t, right? So I'm going to cube root both sides. So cube root both sides is like power 1/3. So x to the power of 1/3 is equals to cosine t. Agree? So in other words, cosine square t is equals to x to the power of 2/3. Similarly, y is equals to sine cube t, right? So I don't want the cube. So what I'll do is I will make y to the power of 1/3 equals to sine t. So sine square t is equals to y to the power of 2/3. Now I know that sine square t plus cosine square t is equals to 1 by trigo identity. So I know that my y to the power of 2/3 plus my x to the power of 2/3 is equals to 1. So I have shown this Cartesian equation. Okay, so let me write it the way they want. X to the power of 2/3 plus y to the power of 2/3 is equals to 1 shown. Alright. Now, moving on to part D, the region C, the line x equals to 0 and the line y equals to 0 is rotated through 2 pi about the y-axis. Find the volume of revolution of the solid form give your answer in 3dp. So, what I'll tell students to do is, before you even do anything, first write what is the integral that you need to integrate to get the volume. So, the volume, because I'm going to rotate it about the y-axis, okay, so it is going to be pi x squared dy. Okay, then you need to determine what are these values here. All right, so what I'll do is I will sketch this in my GC. So change the mode to parametric mode, type in these equations here, change the windows, okay, make sure that the t value is from 0 to pi over 2. Okay, and when you do that, this is the graph that you get. Okay. Okay, and here's 1 and here is 1. Okay, so this is the equation that we are looking at, and they want the region bounded by the curve, which is here. X equals to 0 and y equals to 0. So this is x equals to 0, y equals to x equals to 0, y equals to 0. Anything else? Yes, no. So basically this is the region that we are looking at. Okay, and we know that the volume that we are interested in is pi x squared dy, right? Okay, and it's going to be from 0 to 1. Okay, y equals to 0 to y equals to 1. So now we can go about doing this. So there are two ways, right? You can do the parametric, but parametric integration is not in the syllabus anymore. So why do they ask you to do 8C? Well, it is because from this equation here, x to the power of 2/3 equals to 1 minus y to the power of 2/3, right? So now what I need is x squared. So to get rid of the power 1/3, what do I need? I need to cube it, right? So it's equals to 1 minus y to the power of 2/3 cube. Okay, so let's do it. So I have this 0, 1, 1 minus y to the power of 2/3 cube dy. Next, this is a definite integral, right? So did the question say they need exact value? No, they say correct to 3 dp. So don't do any integration. Type it into your GC. Okay, once you type this into your GC, you'll get a value of 0.479, okay, when rounded off to 3 decimal place, and that would be your answer for 8D. Okay, now moving on to question 9. Okay, maybe I should make it smaller. Okay, done. So now we have question 9. The man M is at the top of the mountain, which is of height h kilometers. Okay, so from here to here is h. The radius of the earth here to here is r. It's constant. The furthest point on the earth's surface that the man can see is point P, such that MP equals to x. Okay. Okay, where O is the center of the circle. So we have theta is here and O is the center of the circle. And we also know that, right, this is a tangent, right? MP is a tangent to the radius. So therefore, this is 90 degrees. Okay. So we need to show this, right? Okay. If one look at this, this seems like a binomial question, binomial expansion question, because h is negligible. So h is, sorry, the height of the man is negligible. Sorry, no, it's not. This part is, but because they say h is small compared to r, so very likely it's a binomial expansion question. But let's do this portion first. So for this portion here, we have x equals to 2hr to the power of half, and this, we need to show that, right? So how do we find x? Well, I also know that the radius, here to here is the radius, OP is also the radius, right? So by Pythagoras theorem, I know that r squared plus x squared is equals to h plus r whole thing square, right? So let's write that in. Okay. So by Pythagoras theorem, okay, so once you're done with that, we need to expand it, right? Because you want to make x the subject. And you notice that there is here, well, this is x the subject. Okay, so let me bring it over. So I have x squared, okay, equals to r squared plus 2hr plus h squared, then minus r squared, right? So this one can cancel off. So I have 2hr plus h squared equals to x squared. But finally, I need to show that x is equals to 2hr to the power of half 1 plus h over 2r to the power of half, right? So how do I do that? So basically, they are going to take out 2hr. So I'm going to take out 2hr. So when I factorize out 2hr, here will be left with 1. Then here will be h over 2hr. Okay? So it's like you have a plus ab. When you take out a, what is left in the bracket is basically a over a plus a over b over a, or what you have taken out. And therefore you are left with a over 1 plus b, right? But if I were to factorize this and I want to take out AB, what happens? So it will be A over AB plus AB over AB. right? So this one will be 1 and this one will be 1 over b. Okay? So basically, if you look at what you need to prove, they are actually telling you, hey, you're supposed to take out your 2HR. So that's what we did. Okay, and then once we do that, we are very close to what we have, right? So in order to get x, I will square root, right? Square root is the same as power half, and I need to power half for everything. Okay, so I've shown what they require me to show. Okay, so now I have this equation here. What do they want me to do? It's given that h is small compared to r. If h is small compared to r, this means that h over r is small. I want you to show that sine theta is equals to this. Is it, which is x, over hypotenuse, which is r plus h. Okay, so let's first write in the sine theta equals to x over r plus h. All right, and we also know that we need to simplify it to this, where alpha is h over r. So phi goes to h over r, and we need to show eventually that we get this. So sine theta equals to, roughly equals to 2 alpha to the power of half, and then 1 minus 3/4 alpha. This is what we need to show. Okay, so now let's go here. We have x, which is in terms of this, so we'll need to use it. So let's put it in 2hr power of half, 1 plus h over 2r to the power of half, r plus h to the power of minus 1. Okay, so next, once I've done this, okay, I need everything to be in terms of alpha. There is no h or r, right? So I know that here I already see my h and r, so I can immediately change this h over 2r to half alpha. For this one, I can take out my r. Then I have 1 plus h over r to the power of minus 1, right? Okay. So next, I'm going to combine these two together. So I have 2hr to the power of half. And then anything to the power of minus 1 is the same as this, right? 1 over it. So r to the power of minus 1 is 1 over r. Okay, this one I already have my alpha. And now this, I have my h over r. I can change it to alpha already. So what do I do with this? So remember that r is the same as r to the power of half times r to the power of r half, right? So this is what I'm going to do. So okay, power half, r power half, r power half. Okay, so maybe what I'll do is I'll just put this in terms of power half. Then I can cancel this away. Okay, then I have 2h to the power of half and also r to the power of half. So I can make them into a single bracket, right? Because if you have a, b to the power of n is equals to a to the power of n, b to the power of n. So similarly, if you have a to the power of n over b to the power of n, you can write it as a over b whole thing to the power of n. Okay, so this portion I'll write it as 2h over r to the power of half. Okay, and now I have my alpha again because I have my h over r. Okay, so this is 2 alpha to the power of half, right? Or 2 to the power of half alpha to the power of half. But I don't need to do that because at the end of the day, they want me to show it as 2 alpha to the power of half. So I'll just leave it as this. Okay, let me erase this portion here. Okay, so I know that this can be rewritten as 2 alpha okay, so I have this. Okay, and I know that I already have this portion here. So I need to show that this portion here is this can be approximated to 1 minus 3/4 alpha. And if you look at this binomial, it is power half. This one here is power minus 1. So we know that based on our formula list, we can do a expansion using this, right? Okay, so this is the MF27, okay, which will be provided to you during your A-level exams. So you do not need to memorize these formulas. Just need to remember that you can only use this when your mod x is lesser than 1. So we know that h over r, or our alpha, is small, right? So it's going to be lesser than 1. So we can use it. Also, we need to start off with 1, positive 1, okay, here. And if you have to look at what we have here, yes, they both already start off with 1. So we can use this equation here. Okay, so the MF27 is very useful. Make sure that you do know where to find it. Okay, so this is a 8-page document. Okay, I know that for some students, they find it very bulky to bring such a big stack all the time. So I've also made a condensed version of MF27, okay, which contains only the formulas that you need for H2 math, because the MF27 is for all the various exams, your H1, H2, and H3 math, as well as further math. So there are many more equations, but I have already condensed them into 2-page so that you can actually print it out on a piece of paper, a single piece of paper, if you want to print front and back. So if you're interested, do download it. This is also what I see for most of the common the WAs as well as the promos. Schools use this instead of printing so many pages. So you do download it if you are interested in it. I'll provide a link in the description below. Okay, so basically what we are going to use is we are going to use this formula here, right? Okay, for the binomial expansion, which is these two here. Okay, so I'm going to expand this two using the binomial expansion. So let's do it. So I keep this alone. Then I'm going to expand this. And I know that I only need one term, right? Because it's only until alpha. Okay, I only need the first two terms of the binomial expansion. So let me blow this up here. Okay, so it's basically 1 plus x to the power of n equals to 1 plus nx. I don't need to have the x squared terms and so on, because based on what I need to prove, I just need it to here. So this is what I'm going to do. So using the formula booklet, it will be half times half alpha, which is 1/4 alpha. Then this one will be 1 minus alpha. Okay, then let's expand it. So I have 1 minus alpha plus 1/4 alpha, okay, which is approximately equals to 2 alpha to the power of half, 1 minus 3/4 alpha shown. Okay, so I've shown part B. Now let's move on to part C. So in part C, we are told that the man has a scientific instrument which enables him to estimate the angle PM and the horizontal. So given that the angle is 2 degrees and the radius is this, find the estimate of this. So what we know from here is the horizontal will always be perpendicular to the vertical, right? So height is going to be vertical. Okay, so in other words, right, the horizontal will be perpendicular to this line here, MO. Okay, because here height is perpendicular, is the vertical, right? Horizontal is perpendicular to the vertical, right? This is vertical, and vertical always have height, right? So here's a bit of h. So the horizontal is basically a line perpendicular to the vertical. Okay, so now we know that the angle between PM and the horizontal. So I've drawn it here, a line passing through P and then perpendicular to MO. Okay, and I know that this is 2 degrees. All right. And they give me that the radius R is 6375 kilometers. So they asked me to find what is alpha and H. Okay, so what I'll do here is, I know that here is 2 degrees, right? So this is a right angle triangle here. So if I were to call this F, so I know that MFP is a right angle triangle. Similarly, I know that this is a tangent, right? MP is a tangent to the radius here. So I know that MPO is also a right angle triangle. Okay, so now here is 2 degrees. So this angle here, let me call it, let me use it another color. This color here. This angle here, let me call it angle Y, right? So I know that this is a right angle triangle. That means Y plus 2 degrees, angle Y, okay, plus 2 degrees is equals to 90 degree, right? Because here's 90, so these two must add up to be 90. Similarly, this is a right angle. So that means theta plus, it also has angle Y, is also equals to 90 degree, right? Because here's 90, so this two must add up to be 90. So what does it tell you? It tells us that theta is 2 degrees. So they are trying to tell us that theta is 2 degrees. Okay, so you are given theta equals to 2 degrees, R equals to 6375 kilometers. You are going to find what is alpha, what is H. Okay, so we know that theta is 2 degrees. You can sub it in. Then they only ask us for estimates, right? So you use your GC to solve for alpha. Okay, then once you found alpha, you are given R, right? You can find H. So let's do it together. So we are given that theta equals to 2 degrees, and then our R is equals to 6375 kilometers. Okay, so we need to find what is alpha first, right? And we will use this because they only need an approximate value. So we know that sine 2 theta is equals to 2 alpha to the power of half 1 minus 3/4 alpha. So just use your GC. Don't try to solve it yourself. Okay, you'll just need an approximate value. Okay. Okay, so this is what I got from the GC, 6.0954 times 10 to the power of minus 4. So once they have found alpha, I know that alpha is equals to H over R, right? So therefore H is equals to alpha times R. So it's 6.0954 times 10 to the power of minus 4 multiplied by 6375. So it will give me 3.89 kilometers. So H is 3.89. Moving on to question 10. Question 10 is a vector question. So let's take a look at this question here. So the point A has coordinate 0, 2, minus 3, and we have a line with equation of this. So it's the equation of a line in Cartesian form. So for vector question, it's easier to use the equation in the vector equation of the line. So we'll convert this to a vector equation of a line, right? So recall that if you have an equation of line written in the form of this, let me write it. X minus A, Y minus B, X, Z minus C, D, E, F. Okay, then we can rewrite it in the form of A, B, C plus lambda D, E, F. So if I had to take a look at this, okay, this one is X plus X minus 0 over 2, right? Okay, so this equation of the line, I can rewrite it as R equals to 0 minus 1, 2 plus lambda 2 minus 3, 1. Okay, so and I'm going to write it this way so that I can use it easily for the rest of the questions. Okay, so I'm given A, which is this point. Okay, and this line here, I need to find the Cartesian equation of the plane which contains A. So a plane that contains A and is perpendicular to L. So this is L and is perpendicular to L. So whenever we have a plane, we need the normal vector, which is a vector that is perpendicular to the plane. Okay, and then we need a point. So we already have a point, which is A. Okay, and we also know that this plane is perpendicular to L. That means the normal vector is parallel to the direction vector. So n of this plane can be 2 minus 3, 1. Okay, so with that, we can find the equation of the plane. So let's write that in. So we let OA, oh, don't need to let because they already give us A. So we'll let, so OA is 0, 2 minus 3, right? And we know that L can be written in this manner. And we know that the plane is parallel, plane, or L is perpendicular to plane, right? So therefore, normal of plane is 2 minus 3, 1. So equation of plane pi, okay, can be written as R dot 2 minus 3, 1 dot A, which is 0, 2 minus 3, equals to this one dot 2 minus 3, 1. Okay, so this will give me minus 9, right? Okay, and then this will give me 2x minus 3y plus z. So 2x minus 3y plus z equals to 9. I need to write it as this form because the question says they want Cartesian equation. Okay, so you cannot leave it in terms of r dot 2 minus 3, 1 equals to minus 9. That is the vector equation. Okay, we don't want that. We need this. Okay. Next, B, hence or otherwise find the coordinates P on L which is closest to A. Okay, so find the coordinates P on L which is closest to A. That means you will need to find the point on P. P is the foot of perpendicular from A to L, right? So this is L and this is A. I want to find the point P such that A is close, the point on L where A is closest to. So basically it is the foot of perpendicular. So to do this type of questions, I know that P lies on line L, therefore P takes the equation of L. Okay, and we know that the equation of L is this. So I can say that OP is equals to 0 minus 1, 2 plus lambda 2 minus 3, 1. Or I can just rewrite it as 2 lambda minus 1 minus 3 lambda 2 plus lambda, okay, for some value of lambda. So it's for a particular value of lambda, right? And I can find AP, which is OP minus OA. So it is 2 lambda minus 1 minus 3 lambda 2 plus lambda minus OA. So OA it's 0, 2 minus 3. Okay, so with that, I know that AP is 2 lambda minus 3 lambda and then 5 plus lambda. Okay, then I know that AP is perpendicular to L. That means AP dot the direction vector of the line, and the direction vector of the line is simply 2 minus 3, 1 is equals to 0. So I'm going to do a dot product, 2 lambda minus 3 lambda, 5 plus lambda dot of this. Okay, so I'll have 4 lambda, expanding it out, 4 lambda, okay, plus 9 lambda plus 5 plus lambda equals to 0. Solving for lambda gives me negative 1. So I want to sub in lambda equals to negative 1 into OP. So OP, when I sub in lambda equals to minus 1 into this, I'll get OP equals to minus 2, 2, 1. Okay, so the question asks us for the coordinates of P. So I need to write coordinates. I cannot write this as OP. I need coordinates. So it will be given as minus 2, 2, 1. Okay, so this is the answer for B. Okay, moving on to part C. So what are we asked for in part C? So the line M passes through the point with coordinates 4, minus 5, 10. Okay, and P. Okay, so it passes through this point and point P. The line N lies in the same plane as L and M. Okay, so N lies in the same plane as L and M. Find a Cartesian equation for N if N is the reflection of the line M, the reflection of the line M on the line L. Okay, so what we know is, okay, we have L. Let me draw it here. I think it's easier. So I have L here. And then I have this point P here that I found, right? P is minus 2. Maybe I should write it here. Minus 2, 2, 1. Okay, let me erase this. Then I know that this is line M. Okay, and line M also has another point, which is 4, minus 5, 10. So it has 4, minus 5, and 10. Okay, so this is what I have. Then next, so this is line M. So if I reflect line M about line L, okay, I will get this line, which is line N. So they are asking me what is the equation of line N. Okay, so let's do it. So I will first let this be C. So let C be 4, minus 5, 10. Because they didn't say what point it is, right? So later I need to say, oh, this point minus 4, 5, 10. It's going to be very difficult, so define it. So I'm going to call this C be 4, minus 5, 10. Okay, so what I need to do this here is I need to find what is C prime, which is the reflection of C about line L. Okay, so in order to do this, I need to first find what is F, right? So find what is F first. Okay, so to find what is F, I know that F lies on L. So I'll first say let F be foot of perpendicular from C to L. Okay, so since F lies on the line L, I know that OF is equals to the equation of the line L, okay, which is like OP just now. It's just for a different lambda value. So it's 2 lambda minus, let me do it. So it's 2 lambda minus 1 minus 3 lambda 2 plus lambda, right? Okay, and let's find what is CF. So CF is OF minus OC. Okay, so OF is this, right? 2 lambda minus 1 minus 3 lambda 2 plus lambda, and OC is 4 minus 5, 10. So this will give us 2 lambda minus 4, 4 minus 3 lambda minus 8 plus lambda. And I know that CF is perpendicular to L. So this 2 lambda minus 4, 4 minus 3 lambda minus 8 plus lambda dot the direction vector of L, which is 2, 3 minus 1, 2 minus 3 and 1 is 0. Okay, so you do a dot product and you solve for lambda, you should obtain an answer of lambda equals to 2. So therefore we know that OF is equals to 4 minus 7, 4. How do I get it? I sub in lambda equals to 2 into this equation here to find OF. Okay, then what I know is that, right, OF is the midpoint of C and C prime, right? So if you use your ratio theorem from the MF 27, which is on the second here. So if I have a point dividing AB, so I have A and B, in the ratio of lambda is to mu. Okay, and then this is my C here. So maybe this one, let me call it O. This is A, this is B, then this is C, okay? Then C is equals to lambda times B plus mu times A over lambda plus mu. So now I have my C, my F, my C, and my C prime, right? So because F is going to be a midpoint, so here is 1 is to 1. Okay? So to find, so OF is basically 1 times OC plus 1 times OC prime over 1 plus 1, which is 2. So in other words, 2OF is equals to OC plus OC prime, or OC prime is therefore equals to 2OF minus OC, right? So let's write it. So I know that, okay, OC is equals to 2OF plus OC, okay? So you sub it in, okay, you sub in everything, you will get 4 minus 9 and minus 2, okay? So once I've gotten OC prime, okay, which is 4 minus 9 minus 2, I know that P is this, right? So to find the equation of the line, I just need to find the direction vector C prime P, or PC prime, the same, which is equals to OC prime minus OP. Okay, then you take this 4 minus 9 minus 2 minus 2 to 1. Okay, and it will give me 6, negative 11, and negative 3. Okay, and I know that the line will pass through either P or C prime, right? So I know that N is the equation, the equation of line N is R equals to, can use P or C, so maybe I will use P, which is minus 2 to 1. Okay, it doesn't matter, you can use P, you can use C, plus mu, okay, 6 minus 11 minus 3, where mu is real. Okay, but this is the vector equation. The question asks for Cartesian equation. Okay, so let's make this into a Cartesian equation. So the Cartesian equation will be x plus 2 over 6 equals to y minus 2 over minus 11, which is equals to z minus 1 over minus 3. Okay, so this is the answer for question 10C. Moving on to question 11. So in question 11, we are given the variable a is such that the rate of increase of a with respect to time t is proportional to the product of a and 10 minus a. So to write this as a differential equation, we'll write it as dA dt, because rate of change or rate of increase simply means that the rate of change is positive. You don't need to add a negative sign. So dA over dt is proportional to a and the product of a and 10 over a. So you can write dA dt as equals to ka times 10 minus a, where k is a constant. Okay, then initial value of a is 2. That means initial, when you see initial, that means when t is 0. Okay, this is the value of a is 2. When t is 5, a is 4. Okay, and we are asked to write down the differential equation expressing relationship between a and t and find the time at which a equals to 8. That means we first need to solve the differential equation so that we can find what is t when a is 8. Okay, give your answers to 2 decimal places. Okay, so let's do it now. So let's write out the differential equation that we have, okay, which is dA dt is k a 10 minus a. Right? Okay, and I know that k is a constant. Okay, now that I've written this, the next thing I need to do, I also know that when t is 0, a is 2. And also when t is 5, a is 4. These are essential because later I need to find my constants, my k and also my arbitrary constants. So I'll need to sub these in order to find them. So they give us 2 sets of values of t and a. This means that we have 2 constants. One of it is k, one of it is our arbitrary constant. So now we need to solve this differential equation. So by variable separable method, right? So I'll divide a and 10 over a to the other side. So 1 over a 10 minus a dA equals to k dt. Okay. Then for this, in order to integrate, I need to apply partial fractions, right? Okay, is equals to x over a plus y over 10 minus a. So I need to find x and y, right? So I can rewrite this as 1 equals to x 10 minus a plus y a. So when I sub in a equals to 10, I get y equals to 1 over 10. When I sub in a equals to 0, I get x equals to 1 over 10, right? So I know that this can be written as 1 over 10a plus 1 over 10 minus a dA, k equals to kt plus c. Okay, let me erase this. Okay, so now let's do the integration. So this, when I'll just take out 1 over 10 and write it as 1 over a plus 1 over 10 minus a. Okay, so I have integrate 1 over a, I get ln a. Integrate 1 over 10 minus a, I get negative ln 10 minus a. Okay, I'll multiply 10 on both sides, so I have 10 kt plus 10c. And this I'll get ln a over 10 minus a. So these are the rules of logarithm. Okay, so next I have a over 10 minus a is equals to e to the power of k1t plus 10c. Okay, so where k1 is equals to 10k, they're just constants, right? So you can just change it to k1. Then later we don't need to keep writing the 10. Okay, then I can also change. So remember, this one is e to the power of k1t plus 10c, can be written as e to the power of k1t times e to the power of 10c. And e to the power of 10c is essentially a constant, right? Because this is an arbitrary constant. So let's call this arbitrary constant b. So this will be equals to b e to the power of k1t a 10 minus a. Okay? So next, I need to find out what is b and what is k1. So when t is 0, a is 2, right? So sub in a goes to 2. So 2 over 10 minus 2 is 8 is equals to b e to the power of k1 times 0. 0 times anything is 0. So e to the power of 0 is 1. So therefore, we know that b is 1 quarter. Next, I also need to find what is the value of k1. So I need this second set of values. So when t is 5, a is 4, right? So when a is 4, let me sub in 4 over 10 minus 4 would be 4 over 6, which is 2/3. Okay, and it is equals to 1 quarter e to the power of k1t, and t is 5. Okay, so let me just cancel this. So I'll multiply both sides by 4, so it will be 8 over 3 equals to e to the power of 5 k1. So in other words, I know that k1 is equals to 1/5 ln 8 over 3. Because I ln both sides, I'll have 5 k1 equals to ln 8 over 3, right? Okay. So now I have found k1. I need to answer the question. I'm supposed to find the value of t when a is 8, correct to 2 decimal place. So let's do it. So I have a is what is it? A is 8. Okay, a is 8. So let me put in a is 8. So when a is 8, so I have 8 over 10 minus 8. So 8 over 10 minus 8 is 4, right? Equals to 1 quarter e to the power of 1/5 ln 8 over 3t. So I can put the t here. Okay? So it's basically equals to 16 equals to e to the power of t over 5 ln 8 over 3. Okay, so I'll ln both sides. So 16 ln 16 is equals to t over 5 ln 8 over 3. So t is essentially equals to ln 16 divided by 1/5 ln 8 over 3. Then you just need to type this 16, not 6, sorry. So then you just need to type everything into the calculator. Okay, and you will get a value of 14.13 when rounded off to 2 dp. Okay, and t is in, did they have any units for t? No, they didn't. So just leave t as value, don't need units. So t is 14.13. So that's for 11a. Moving on to 11b, find the value of a when t is 24, giving your answers to 2 decimal place. Okay, so now we know that from part A, okay, we have a over 10 minus a is equals to, where is it? This portion, right? So 1 quarter e to the power of k1 is 1/5 ln 8 over 3. So it's t over 5 ln 8 over 3. Okay, so now I need to find a when t is 24, right? So when t is 24, okay, I can just type this whole thing into the calculator. 10 over a equals to the power of 24 over 5 ln 8 over 3. The easiest way is to type this whole thing into the calculator. So I have e to the power of, e to the power of 24 4 over 5 times ln 8 over 3 times 1/4, which is around 27.707. Okay, so basically do a cross multiplication. Okay, so let me just erase this. So this is A. So I know that 27.707 is equals to times 10. Okay, is equals to 1 plus 27.707 A. So solving for A, I'll get A equals to 9.65 when rounded off to 2 decimal place. So that's for part B. Now let's go on to part C. Write the solution of the differential equation in the form A equals to ft and sketch the graph of A against t. Okay, and it's worth 4 marks. Okay, so now we know that we have this equation here, A over 10 minus A equals to 1/4 e to the power of t over 5 ln 8 over 3. Now, we need to make A the subject, right? So that we can type that into our GC and get the shape out of it. Okay. So recall that in the differential equation chapter, we learned that e to the power of ln A is equals to A, right? If I have e to the power of ln t ln A is equals to e to the power of ln A to the power of t, which is equals to A to the power of t. So this is what I'm going to do now. So I'm going to put this as the power. So it's 1/4 e ln 8 over 3 to the power of t over 5. Okay. Okay. Next, this, when you have e to the power of ln A to the power of t is equals to A to the power of t, right? So this whole thing I can simplify as 8 over 3 to the power of t to the over 5. Okay? Now that I'm done with this, I need to make A the subject, right? So let's do a cross multiplication. So I'm only going to take this 4 multiplied by this. So I'm going to treat this as a fraction like this. Okay? You can also treat it as 1/4, it doesn't matter. So I'm going to take this A times this 4 and this whole thing 10 minus A multiplied by 8 over 3 to the power of t over 5. So I have 4A equals to 8 over 3 to the power of t over 5 times 10 minus 8 over 3 to the power of t over 5 times A. Now I'm going to bring this over because I want to make A the subject. So I need to put all terms with A together. So I have 4A plus 8 over 3 to the power of t over 5. A equals to 8 over 3 to the power of t over 5 times 10, right? Now I'll factorize out A. Okay, so A is equals to 10, 8 over 3 to the power of t over 5 over 4 plus 8 over, this is not 5, sorry, 8 over 3 to the power of t over 5. All right, so this is what I have for A. So now that I have written this equation for A, I am supposed to sketch the graph of A against t, right? So let's do the sketch. So type it into your GC. You'll notice that you will, some things to note, right? So type it into your GC. We'll ignore values of t that are negative because, why? Because t is time, right? Time cannot be negative. So we'll start from 0, all right? And we already know that when t is 0, a is 2. In fact, if you sub it in or you go to your GC, when t is 0, a should be 2. If you don't get that right in the graph on your GC, that means something must be wrong. If you type into the GC, it looks like there is an asymptote somewhere here, right? And if you keep scrolling, you'll notice that the a value is somewhere around 10. Okay, the asymptote is at a equals to 10. I'll explain more later. So this is the, let me call it ft. Okay, because they say that this is ft, right? In the form equals to ft. So I label this as equals to ft, then I don't have to write so much. So I just label this equation here as a equals to ft. So this is the answer. And now I want to explain why do you have an asymptote at a equals to 10. Okay, so let's write out this equation here again. So I have a equals to 10, 8 over 3 to the power of t over 5 over 4 plus 8 over 3 to the power of t over 5. Okay, so next what I'm going to do is I'm going to divide everything here by this 8 over 3 t to over 5. So all terms I'm going to divide by 8 over 3 to the power of t over 5. So this divided by 8 over 3 to the power of t over 5, I get 10. This one when I take 4 divided by 8 over 3 to the power of t over 5, I will get 4 times 8 over 3 to the power of negative t over 5. Okay, then this one divide, I'll get 1. Okay, now when t tends to infinity, okay, this is the only part with t, right? So if you have a to the power of negative x, when x tends to infinity, this whole thing will be approaching 0, right? Okay, so same thing whenever you have a negative power, okay, as the negative power becomes extremely negative, the whole thing will be very close to 0. So I know that 8 over 3 to the power of minus t over 5 will tend to 0. So 4 of this will tend to 0, right? So 4, 8 over 3 minus t over 5 plus 1 will tend to 1. This is 0, this is 1, right? So 10 over this will tend to 10 over 1, which is 10. So therefore, as t tends to infinity, a tends to 10. So that is why we have an asymptote at a equals to 10.
For more math resources, visit mathandsg.com. If you like this video, do like and subscribe. For more math resources, visit mathandsg.com.